Hi all, welcome back to the channel. I hope you all are doing perfectly fine, and we will see now today's daily challenge, and let's try to solve it together. Okay, so the maximum amount of money a robot can earn. You are given an m cross n grid. Okay, so the whole grid m cross n is given to you, and there are some coins in those grid. Okay, so the robot starts from the top left corner of the grid, 0, 0 position, and wants to reach the bottom right corner, m minus 1, n minus 1. Robot can either move right or down at any point. The grid value contains a coin ij in each cell. Okay, so now the coin's value can also be negative. So if the coin's value is greater than equal to 0, the robot gains those many number of coins. But if the coin value is less than 0, the robot will encounter a robber, and the robber steals the absolute value of this many number of coins. Okay, the robot has a special ability to neutralize the robbers in at most two cells on its path and prevent them from stealing the coins in those paths. So instead of uh, being negative in those two cells, you will get a 0. Okay, so yeah, if coins is less than 0, it means there is a robber, and at most two positions the robot can neutralize the robbers, okay, preventing it from stealing coins in those cells. Note the robot's total coin can be negative. Return the maximum profit the robot can gain on the route. So you need to return the maximum amount of profit the robot can gain by optimizing which two robbers you want to neutralize, which robbers you want to remain, and which particular path you should follow while you are going to from this to uh, from the top right to the top left to the bottom right. Okay, so from 0, 0 position you want to reach m minus 1, n minus 1. I hope you did understand the problem statement. The problem statement understanding is not difficult at all in this problem. And if you see, you should definitely try this problem on your own first and then only continue watching the video. So yeah, after you have tried, let's go and solve it. Now you see that if there was no negative coins and the robots are also do not have this particular skill of neutralizing robots, then this becomes a very simple DP on grids problem, which I have explained multiple times. uh, what do that become? Okay, so if let's say the robot is allowed to go from a particular cell to this cell and this cell, it means that a particular cell I comma j, it can be reached from two cells, either this cell or this cell. Okay, so it means that it can be reached from I minus 1 j cell, and it can be reached from I j minus 1 cell. Okay, and if this is the case and the problem is very simple, then you can simply do dpij. If you want to just steal coins without thinking about robbers and all, you can just maximize dp I minus 1 j, okay, plus not plus, maximize the dp I minus 1 j, dp I j minus 1 out of these two cells, which from which choosing which path would have been given me the maximum value, and the particular count or the particular value of the grid. Okay, plus the grid ij. You want to take the coins in the grid ij position also, and you also want to choose the maximum path among two possibilities. Okay, so at every cell, if you try to see, there are exactly two possibilities that you can come from the top, or you can would have come from the left. Okay, because you are only allowed to move this way and this way. Yeah, that is what you could have done. But you see, there is an extra criteria here, is that you are allowed to do at most two neutralizations. Okay, and these neutralizations can happen, only makes sense to happen when this a particular grid has a cell which is less than 0. It means a robber is there who is going to steal that many number of coins. So instead of two states of dp, now we have another state which is nothing but the, let's say, the number of neutralizations left. Okay, so you can call it left. So left will tell me this is the three states, and left will tell me the number of neutralizations which are left. Again, in this problem, uh, surprisingly, it is easier if you follow this recursive method first and then go to the memoized method. Okay, memoized or recursive DP, and then if you follow iterative, and in this problem you can also space optimize it. In most of the problem you can do it. So yeah, up till this much only if you do, it will give you an accepted solution, and I will show you the whole idea behind this too, and then I will request you to solve these two methods also on your own. This method, and this method all will be accepted solution, so no problem with that. But there will be difference in time complexity and space complexity. So let's try to write the recursive solution at first. In the recursive solution, we will see that at a particular cell ij, you can move either to these two cells, okay, I plus 1j, or you could have also moved to ij plus 1, okay. And when this particular cell has a uh, coins ij, when coins ij is less than 0 and the left is greater than 0, and left means how many neutralization I can do, that is also possible, and the coin is also greater than 0, then I will maximize that with this left minus 1 also. So instead of what I will do, so what I used to do, I plus 1 j, instead of going to this cell also, these two cells also, I will try to do something like this. So dp of I plus 1j, and also left minus 1. I told the third dimension of the dp can be left minus left. So it will be left minus 1 because I am using one of my neutralization powers. Okay, total neutralization power is 2. So I am using one of my neutralization powers. So yeah, that I am doing. And also I could have done I j plus 1 and left minus 1. Okay. So I hope that is simple to understand. And of course, we will not write the recursive iterative solution directly, or the recursive solution directly here. Memoized solution directly here. So we will first try to write the recursive solution. So let us just start. It is not very difficult, and recursive solution, as you know, are always mostly intuitive. Okay, most of the problems, the recursive solutions look very intuitive. So we'll start with that. So we have this m and n values, and I want to have another return which will give me, let's say, take coins. Okay, I have this function which will take in its input this vector coins. Okay, so you have this coins as the input. You have int I, int j. Okay, I hope you know what that means. They are nothing but the coordinates, and you also have this left value, and yeah, only this many you have for the recursive one. So and you want to return what? You want to start from the 0, 0 cell. So you definitely want to start taking coins from the 0, 0 cell, and then at max you have two number of neutralizations left in the beginning. So the left value will be 2. I hope that is not at all difficult to understand. Now we need to write few base cases here. So there is a possibility that when you are at these positions of the grid, okay, when you are, let's say, in this position, you are trying to step over here, okay, or you are this is no problem, but you are trying to step over here, or when you are here you are trying to step over the grid, then you need to take care of those. Okay, so if I greater than equals to m, or j greater than equals to n, uh, you need to return what? Int min. Why you are returning int min? Because you are told to maximize the whole value the robot can take. So if you are stepping out of the grid, obviously you will return int min. Okay, and quite naturally, you also have to, you can also just paste this line. So yeah, after you have pasted this line, you have the m and n. Okay, so uh, yeah, now you can go on with writing another base case. What is when? So one also we need to understand that when we reach the final m comma n, m minus 1, n minus 1, okay, then what we will do? Okay, write the base case for that also. So for that, first we have the count of the points that will be added or subtracted. This can be negative also. So I equals to m minus 1 and j equals to n minus 1. What does this mean? Arrived. We have arrived destination. So what to do in such a case? We will check again that what is the destination value. So coins ij. If coins ij is less than 0, okay, and you have some neutralization left, okay. So I will just check if you have some neutralization left, that is left is greater than 0, then you can return maximum of 0 comma coins ij. It means that you might have to neutralize it if coins is negative, okay. If coins is negative, you might have to neutralize it if you have the number of neutralizations greater than 0, else you can simply have to return mm, this CNT only. And if you remember, I have stored this value in a CNT, so you can just use that. So yeah, I have uh, written the base case also. Now what you can simply do is write the result. Okay. Yeah, not so simply, but you can approach to writing it via this. So from a particular cell, what are the two cells which you can go? Again, I plus 1 j and ij plus 1. Okay. So you can just take the maximum among both of them, as you do would have done in a normal DP without the third variable. Okay. So taking coins I j plus 1 and left. Uh, that is all you do, but you also add the count. Okay. So you come from which path? Ij plus 1 or I plus 1 j. Okay. And you go to which path, and you also take the current value of count. Now, again, the choice comes when the count value is negative. Okay. So when the count value is negative and also the number of neutralization left is positive, then you can perform. This is the condition that you can perform a neutralization to a robber. Okay. So uh, let's try to perform that. Result will be equal to again maximum of, you could not have performed also. Okay. So we will keep this result as a choice, and you could have skipped it, skip these cells. Okay. So take coins of coins I plus 1. Again, you could have gone to I plus 1 j, but this time left will be minus 1. Why? Because you are using one of your neutralization powers. So definitely the left which will be there will be minus 1. So again, ij plus 1, again left minus 1. Okay. And I hope it is very clear to you. If you try to simply return this result, I hope the recursive solution is perfectly ready with just this much of code. Let's try to see if it at least these two cases should be correct. Okay, so let's do some debugging. We missed a semicolon here and try to run now. Okay, too few argument, 0 0. Okay, the first argument is nothing but coins. So yeah, I forgot to pass that over here. So just pass it and run and check what kind of thing happens. You see, it does give you an accepted solution, but if you submit it because of exponential time complexity, definitely it will give you a daily. Okay, you got this daily, but don't worry, if you can simply write the memoized solution, so 3D kind of thing, if you can just write with these three states. So you have vector int n, again a vector in 3 int min. Okay, you initialize this whole recursive DP with int min, and if you notice very carefully, I have done 3 because 0, because although there is at max 2, but it can take the third state can take the values 2, 1, and 0. So it needs 3 spaces to live. So yeah, I initialize the dimension as 3, and carefully you should write a vector, vector, vector here also. Okay, and after you have done this, what you can do is perform the memoization. Okay, so if dpij left is not equals to int min, so it is type of a cache memory. I hope I have multiple time explained you how this works. So if it is not the int min, you can just return it. It means that this state has already been filled sometime earlier, and you do not need to do that repetition. You can simply return this dpij left. And at the end, while returning the result or anything, you should always uh, save the state into your DP. Okay, so you are saving the state, and if you are seeing here that the state has already been calculated, do not need to recalculate it again, and suggest that optimization is always sufficient to give you an accepted solution. Uh, okay, so some more debugging. You see, uh, these places need to have a fourth argument as the DP. Okay, because I just now added a fourth argument DP over here also. Okay, so when I am passing to the memoized solution, it needs to have this DP. So let's see. Again, here you should pass the DP. Mm, let's see. Yeah, now it got the accepted. If you submit it, it should give you accepted, but yeah, not much runtime or memory you can expect. Yeah, it did give you accepted, but runtime memory is not so good. But I hope the logic and everything is pretty clear to you, and you are also able to get this accepted solution. Next, you should try to write this iterative DP as well as space optimized. For these, you can definitely follow my DP playlist, which I have in which I have explained in detail how to write the memoized solution. And from going from the memoized to the iterative is a simple thing only. So yeah, that is all. Without extending much of this video, I am ending it here. If you have any doubt, you can ask me in the comment section. I will meet you in the next video. Till then, thanks a lot.